I'm Yusuf.
Hello, I'm Tarek.
We are from the Tanzania National School in Dar es Salaam, Tanzania.
In our video, we will present ecotoxicological impact of cyanide in poorly processed cassava.
Dear jurors, cassava is one of the biggest food resources in one of the biggest countries in East Africa, Tanzania. Major proportion of the Tanzanian citizens' life depend on this produce, even during the most fertile seasons. Yes, we're talking about 500 million people globally filling up their stomachs with this plant. It's easy to collect and prepare, a lifesaver in the harsh conditions of Africa. However, quite sadly, this plant is not the poor man's friend. It's the opposite. It can be a deadly enemy in some conditions. As famine knocks the door of Tanzanian locals, they start consuming this plant without processing it properly. Consequently, a poisonous substance called cyanide does not go off from the produce and starts to pile up in human's body as he or she keeps eating it continuously. After a while, terrible health effects occur, such as acute cyanide intoxication, gouters, partial paralysis, ataxia, or even death. Furthermore, it damages the eyes severely, which is the main focus of our research. Even though this plant is a backup food, we observed far too many cases where people are getting blind, mostly because of eating cassava. We used a variety of procedures to conduct our research. First of all, we distributed questionnaires to Tanzanian citizens in order to understand whether they had any visual effects or not. And then we conducted Snellen's and Ishihara's tests. Results we obtained proved our predictions, which is the significant increase of cyanide significant increase of visual effects among the consumers of cassava. In our video, we are going to talk about 4 major steps, starting with the short explanation of cassava production in Tanzania.
Tanzanian soil has an incredible potential of growing 20 tons per hectare. However, due to the incapability of the farmers and their techniques, in reality it's about 8 tons per hectare of cassava, well below its potential, still being double of the sweet potato production.
Being produced and consumed this high, enzymes of the cassava break down two acetonic cyanohydrin, which are dinamarin and leucostriene. After the breaking down process, cyanide is released, and this is the substance which is deadly to human body. There are 2 types of cassava, sweet ones and bitter ones. And sweet ones are actually tasteless and not bitter. And these ones have 20 milligrams of cyanide per kilogram. And quite shockingly, bitter ones have 50 times as much as the sweet ones. During drought, as you can guess, these toxins are highly produced and consumed. 25 milligram dose of glucosinic cyanides have 2.5 milligrams of cyanide, which is sufficient to kill a rat. Excess cyanide residue from improper preparation can cause acute cyanide intoxication, gouters, and has been linked to ataxia, which is a neurological disorder that affects the ability to walk, also known as konzo. This konzo disease can appear up to 3% in some areas. Symptoms appear 4 or more hours after eating raw or poorly processed cassava. These symptoms are vomiting, vertigo, and collapse. Sometimes death may result within 1 or 2 hours. It can be treated easily with an injection of thiosulfate. However, most of the cases, as it's obvious, this thiosulfate injection is not available in local areas of Tanzania.
In order to successfully conduct our research, we used random sampling method. We surveyed the Tanzanian people within the ethical standards, of course. There were totally 180 subjects in this research, 100 of them being consumers of cassava and 80 of them being non-consumers of cassava, whose ages were in between 18 and 42 years old. Our research project was cooperated with various eye clinics in Tanzania. Ophthalmology professors supervised the research team and shared their area of profession, and raw data was provided by the hospitals. We distributed questionnaires to people, which included questions about sex, occupation, frequency of consuming cassava. These questionnaires also included records on visual acuity tests and color blindness tests. Here's how we got that results. For visual acuity test, we used Snellen's chart. The subjects were positioned 6 meters away from the charts and were asked to read the letters out loud. The letters were read and the results recorded on the subject's questionnaire. For color vision test, we used Ishihara's charts. The charts were provided to the subjects and they were asked to identify the figures within the dotted spots. The result was recorded in the subject's questionnaire, whether if he or she could identify the figures.
There are, of course, some ways of avoiding the harmful effects. You see, societies that traditionally eat cassava generally understand that some processing is necessary to avoid getting sick. For example, just soaking the cassava is not sufficient, but soaking it from 18 to 24 hours can remove up to half the level of cyanide. For some smaller rooted sweet varieties, just cooking is sufficient to eliminate all toxicity. For larger rooted bitter varieties, which are used in the production of flour and starch, must be processed to remove cyanogenic glucosides.
After our experiments, we conducted and gathered data in our tables, as you can see here. We put a summary of all parameters of the 80 and the 100 subjects of the control group and the experimental group respectively in the tables. Table 1 shows that 10% of the control group had history of visual problems, while an alarming 27% of the experimental group had visual problems. Table 2 shows that 18.8% of the control group weren't consuming Gary, and 51.3% were consuming Gary once in several days. Table 3 shows the visual acuity, or the ability of an eye to recognize two separate objects on a line of left and the right arm. Table 4 shows the color vision of consumers and non-consumers of Gary. A 97.5% of the control group was normal color vision, and 92% of the experimental group was normal color vision. In table 5, we can see out of 41 subjects who have visual impairments, 6 are from the control group, and an alarming 35 are from the experimental group. Out of total 10 of the colorblind, 2 are from the control group and 8 from the experimental group.
Honorable jurors, to summarize it up, our results of this study shows that consumers of Gary have poorer visual acuity and color vision than non-consumers. This may be because of the exposure to unsafe amount of cyanide in Gary, which was consumed over a long period of time. Consumption of Gary can increase the incidence of eye problems among the consumers, which may lead to high prevalence of blindness and severe visual impairment in the study area. Thank you very much.